Okay, now the questions from section B. Okay, questions from section B. Ready? What about the first question? The ratio of number of moles of KMnO4 and K2Cr2O7 required to oxidize 0.1 mole of SN2 plus to SN4 plus in acidic medium. So the ratio of number of moles of KMnO4 and K2Cr2O7 required to oxidize 0.1 mole of SN2 plus to SN4 plus in acidic medium. So what you are asked to find? It is the ratio of number of moles of KMnO4 to number of moles of K2Cr2O7. Okay. And that is required to oxidize SN2 plus to SN4 plus. That means your KMnO4 means MnO4 minus, which oxidize SN2 plus to SN4 plus, and you know that in acidic medium, this is in acidic medium, MnO4 minus itself reduced to Mn2 plus. Okay, wait. Like the next reaction is for dichromate, Cr2O7 2 minus, which upon react with the SN2 plus to form, and the Cr2O7 2 minus itself reduced to Cr3 plus, you know that, and SN2 plus to SN4 plus. Okay, this is the basic skeleton reaction which recur here. Okay, and the ratio of number of moles of KMnO4 and K2Cr2O7 required to oxidize 0.1 mole of SN2 plus. Okay, first of all, find the number of moles of KMnO4 required for 0.1 mole of SN2 plus, and find the number of moles of K2Cr2O7 required for the oxidation of 0.1 mole of SN2 plus. Then you simply take the ratio. So if you are balancing this one, here one manganese, here one manganese, here one tin. So this is in a plus an oxidation state. So the change here is change in oxidation state 5 into number 1. So the total change is 5. Here the change in oxidation state 2 into number 1. Total change 2. So you simply multiply here with the 2 and here with the 5. So 2 on manganese, 5 on tin. Enough. So you obtain the mole proportion. What means 5 mole SN2 plus, right? What it means? 5 mole SN2 plus require 2 mole MnO4 minus. 2 mole MnO4 minus. 1 mole SN2 plus require 2 by 5. Therefore, 0.1 mole SN2 plus require 2 by 5 into 0.1. That is the number of moles of permanganate required for the oxidation of 0.1 mole SN2 plus in acidic medium. Like this also, dichromate case. Here 2 chromium, so we require 2 here. Here 1 tin, then 1 tin, fine. So the oxidation state here is plus 6. And what is the change? Plus 6 to plus 3, the change is 3, but 2 chromiums like the. So total change is 6. From plus 2 to plus 4, what is the change? Change is 2 into number 1. So the total change 2. So this you have to multiply with the 3, right? Okay, enough. So it is clear that, so here is 1, right? So it is clear that 3 mole stannous ion require 1 mole dichromate. Therefore, 1 mole SN2 plus require 1 by 3 mole. Therefore, 0.1 mole SN2 plus require Tell me. 1 by 3 into 0.1 mole K2 Cr2 also. Okay. So let me check my question. The ratio of number of moles of KMnO4 and K2Cr2 required to oxidize 0.1 mole SN2 plus to SN4 plus in acidic medium. Fine. So 0.1 mole SN2 plus. The moles of MnO4 minus required is this one. 0.1 mole of SN2 plus. The moles of K2Cr2 required is this one. So you simply take the ratio and choose the answer. So that is 2 by 5 into 0.1 divided by 1 by 3 into 0.1. So this is cancelled. So it will be, this 3 will be on the top, right? So it will be 6 by 5. So the ratio is 6:5. You can choose the choice as A. Is it okay? Okay. So the choice is A. Ready? Moving to the next question. Next question. What about the next question? Listen. The equivalent mass of chlorine in the above reaction. But the reaction is given in below. Okay. Cl2 in presence of NaOH. So the chlorine which disproportionate in NaOH to form NaCl plus NaClO3 plus H2O. Okay, then what is the equivalent mass of chlorine in this case? Okay, so it is clear that this is a disproportionation reaction, right? This is a disproportionation reaction. From 0, the chlorine changes to -1, and from 0, the chlorine changes to +5. Ready? So, in the case of disproportionation reaction, equivalent mass in disproportionation reaction is the, you know that disproportional reaction means a same element undergoes oxidation and reduction, and you are asked to find the equivalent mass of that element, that typical element, here the chlorine. So, how you can find that? You simply choose the equivalent mass of element in reduction half plus equivalent mass of element in oxidation half. And this is how the equivalent mass of a disproportionation reaction find. You find the equivalent mass of each one in separate. Okay. So let me write the reduction half. So it is from 0 to -1 and +5, right? Okay. So the reduction half is this one. The reduction half is Cl2 become Cl minus. Cl2 become Cl minus. So here we have 2 chlorine. So you simply multiply here with the 2. Okay. And how you can find the equivalent mass? Equivalent mass is equal to molar mass divided by total number of electrons changed per mole. So this is 1 mole chlorine. So total number of changes from 0 to -1 into number of chlorine is 2. So the equivalent mass in this reduction half is m by 2. M by 2. What about the equivalent mass in oxidation half? What is oxidation half? The chlorine which turns to chlorate ion, ClO3 minus. If you are replacing this Na plus, then it will be ClO3 minus. But here we have 2 chlorine, so multiply 2 here. Ready? So once again, the equivalent mass is molar mass divided by total change. Total change is from 0 to, here the oxidation state is plus 5, right? So 0 to plus 5, the change is 5. Into such chlorines are 2. So the total equivalent mass is m by 10. And you know that equivalent mass of a substance is the sum of equivalent mass of its components. So the components are reduction and oxidation half. The component equivalent mass of the reduction half is m by 2 plus equivalent mass of the oxidation half is m by 10. What about the sum? It will be 12m divided by 20, right? Yes. So it can be cut with 4. So it will be 3m divided by 5. It will be 3m divided by 5 if you are cutting with the 4. Ready. So this is the equivalent mass of chlorine in this case. Ready. So in our disproportionation reaction, if you are asked to find the equivalent mass, then you split it. Then you split the reaction into 2 half. So that balance each one and find the equivalent mass of each half, and simply sum, you obtain the total equivalent mass of that component in the particular reaction. Okay. So here the choice is 3m divided by 5. So moving to the next question. That is the question. KCl is used as electrolyte in salt bridge. Okay. Electrochemical cell, the galvanic cell will be discussed in electrochemistry. So note it. We will discuss it in electrochemistry. And the question number 4 is also from electrochemistry. Question number 5 is also from electrochemistry. We will discuss it, okay? Question number 6. The oxidation number of chromium atom in CrO5 and K3CrO8 are respectively. It is discussed, right? CrO5. Oxidation number of... And now the question is... question number 6, okay? The question which are dropped will be discussed in your electrochemistry. Don't worry. CrO5, you know, butterfly-like structure. Ready. And you know that the oxidation state is plus 6. And K3CrO8, I think I described it, have 4 peroxy linkage. K3CrO8. And you know the oxidation state of chromium is plus 5 here. So the choice is respective order CrO5 and K3CrO8 is plus 6 and plus 5. You can choose the choice as 3. Okay. Question number 7 in your section B. That is number of electron involved in the reaction when 0.1 mole ammonia dissolved in water. 0.1 mole ammonia dissolved in water. Okay. So ammonia plus H2O, it forms NH4OH. NH4OH. Okay. So the oxidation state is -3 plus 1, plus 1 minus 2, -3 plus 1, -2 plus 1. So there is no change in oxidation state for any component. So there is no electron involved in that. Okay. This is simply a hydrolysis reaction. Ready. So you can choose the choice as 0. Question number 7 is, the choice is 0. What about the question number 8? Question number 8, electrode potential. It is just question from electrochemistry. Question number 9 is also from electrochemistry. We will discuss it, okay? Question number 10. It's also something related to the potential, which means electrochemistry question. Question number 11. When alkali metal reacted with the hydrogen, metallic hydride is formed. That's simply a question from redox reaction. When alkali metal reacted with the hydrogen, let we have sodium with the hydrogen. What happens? Metallic hydride will form. Okay, fine. Sodium hydride is formed. Then, in this reaction, hydrogen oxidized, hydrogen reduced, hydrogen either oxidized, reduced, both oxidized and reduced. What about the case of hydrogen? Hydrogen from 0 to -1, right? So, hydrogen reduced. So, in the formation of alkali metallic hydride from alkali metals, hydrogen will reduced. Is it okay? Okay. The next question. In the case of CH3COH, ethanoic acid, right? The oxidation number of carbon in carboxylic group is CH3COOH, which means C2H4O2. So you're asked to find the oxidation number of carbon. And you know, simply if you're asked to find the oxidation number of carbon, not in a specified manner. Here we have two carbon, a methyl carbon and carboxylic carbon. But here they simply mention that the oxidation number of carbon. So which means that simply the oxidation number of that C2, average OS. And you know the formula, twice the number of oxygen minus number of hydrogen divided by number of carbon will be the answer. 2 into number of oxygen, that is 2, minus number of hydrogen, that is 4, divided by number of carbon, that is 2. So the answer will be 0. Okay, so the oxidation number of carbon will be 0. The choice is B. Next, the question number 13. How many moles of KMnO4 are required to oxidize 1 mole of SN2 plus SnCl2 in acidic medium? This is already discussed. How many mole of KMnO4 minus, which means KMnO4, which means MnO4 minus, required to oxidize SnCl2. You know that in SnCl2 the component oxidized is SN2 plus. Then what do you obtain? This is already discussed in the previous question. That is, you're asked to find the ratio type. Okay, so in acidic medium this one will be SN2 plus and this one will be SN4 plus. So here the oxidation state is +7, here the oxidation state is +2. So the change is 5 into 1 and here the change is 2 into 1. So simply multiply with the 2, multiply with the 5. So here 2, here 5. This already discussed in the previous question, right? How many moles of KMnO4 are required for the 1 mole of SN2 plus? So it is clear that 5 mole SN2 plus require 2 mole MnO4 minus. Therefore 1 mole SN2 plus require 2 by 5. That means 0.4 mole. Or simply 2 by 5. 2 by 5 is in the choice. Okay, so you can choose the choice as 2. Ready? What about the next question? Next question. The next question there is, which of the following compound act as oxidizing agent only? For a species to be oxidizing agent always, it should be in the top oxidation state, right? That is a concept. I think you know that, right? So, the choices are SO2, H2S, H2SO4, HNO2. Agreed. So, for a species, so here the question is, which of the following, which compound act as oxidizing agent only? SO2 here, H2S here, H2SO4 here, HNO2 here. For a species to be oxidizing agent, then that typical one should exist in a higher oxidation state. So here the sulfur +4, sulfur -2, sulfur +6, nitrogen +3. So you know that the sulfur, the maximum oxidation state of sulfur is +6. So first one is not a maximum oxidation state. So it can act as both oxidizing and reducing agent. This can act as reducing agent. So this is always oxidizing agent. because it is in the topmost oxidation state. So you can choose a choice as 3. Question number 15. The average oxidation state of chlorine in bleaching powder is, the composition of bleaching powder is CaOCl2. Okay, so the average oxidation state of chlorine, that here the calcium plus 2, oxygen minus 2, so 2 chlorine should offer 0. And the trend. This is something like this, right? So calcium plus 2, this chlorine minus 1, and this oxygen minus 2, this chlorine plus 1. So to this limb minus 1, then it make up. What about the oxidation state of chlorine? 2 chlorine have 0 oxidation state. Individually they have plus 1, minus 1, but the sum will be 0. Here the average is asked, so you can choose it as 0. What about the next question? When benzaldehyde is oxidized to give benzoic acid, the oxidation state of carbon of aldehyde group change from. So when a benzaldehyde oxidized to benzoic acid, then the oxidation state of carbon of aldehyde group is changed from word to word. So you find the oxidation state of carbon here, then what is the change? And you know that this is a bond to carbon, so there is no polarization. And this is a bond between carbon and hydrogen, so electronegativity towards carbon. Here towards carbon. Here both are same carbon, so there is no net polarization. So if the bond is towards carbon, here minus 2, here plus 2. If the bond is towards carbon, here minus 1. I'm sorry, this is towards oxygen, right? So fine, minus 2 plus 2. This towards carbon, minus 1 plus 1. So the net charge of this is plus 1. So in benzaldehyde, the carbon is in plus 1. What about the case here? Here the electronegativity towards oxygen, here also towards oxygen. So here plus 1. Since there is 2 bond, here plus 2. Here there is no net polarization. So the change is, the total is plus 3. So in the oxidation, what happens? The oxidation state changes from plus 1 to plus 3. Plus 1 to plus 3. Ready? Fine. What about the next question? So a question based on salt bridge. We can discuss it in electrochemistry. And question number 8 also salt bridge question. Question number 19. This is not based on electrochemistry, simply your redox reaction. The number of moles of H2O2 required to completely react with the 400 mole of 0.5 normal KMNO4 in acidic medium. So KMNO4 and H2O2 which are reacting in acidic medium. And you know that in acidic medium, MnO4 minus become Mn2 plus, and here MnO4 minus is an oxidizing end, so H2O2 is a reducing end. If H2O2 is a reducing end, then it will be oxygen. The product will be oxygen. Now you simply balance it. Then we can check the questions. You simply balance it and find the coefficients. So here the manganese is in plus 7 and here it is in plus 2. Here the hydrogen is in minus 1. Here is in 0. Their numbers are 1, 1, 2, 2, fine. What about the change? Change from plus 7 to plus 2, the change is 5. Into number is 5. Number is 1. What about the change here? Change from minus 1 to 0, the change is 1, but number of oxygen is 2. So you simply multiply here with the 2, here with the 5. So 2, 2, 5, 5. This is a basic skeleton reaction. Now let's check the questions. What is the data given and what is asked? The number of moles of H2O2 required, and you asked to find the number of moles of H2O2 required. Okay, and that required completely react with the 400 milliliter of 0.5 normal KMnO4. And you know that for a complete reaction, listen carefully, you know that for complete reaction, number of equivalents of MnO4 minus will be equal to number of equivalents of hydrogen peroxide, right? Number of equivalents of MnO4 minus will be equal to number of equivalents of hydrogen peroxide. Here, what are the formulas for number of equivalents? Number of equivalents can be calculated by normality into volume in liter, or by number of mole into its N factor. Agreed? What is the N factor of permanganate? That is 5. What do you mean by N factor? Change in number of electrons per mole. Per mole, plus 7 to plus 2. For 1 mole of MnO4 minus, the change is plus 7 to plus 2. So the N factor is 5. For 1 mole of H2O2, what is the change? The change is, for 1 mole of H2O2, the change is 2, right? Because minus 1 to 0, 1. Into number of such atoms are 2. So this is the N factor in H2O2, and this is the N factor in MnO4 minus. So the data which given in the question is 400 milliliter of 0.5 mole KMnO4. So normality and volumes of KMnO4 is given. So simply this is replaced as normality of MnO4 minus into volume of MnO4 minus. What do you ask? The number of moles of H2O2. So this can be written like this. Number of mole of H2O2 into N factor of H2O2. Then you can easily find the number of mole of H2O2. So what about the normality? Normality is 0.5. What about the volume? The volume should be in liter, but it is given in milliliter, the question. 400 milliliter means 400 into 10 raised to minus 3. What about the number of moles? That is what we have to find, right? What about the N factor of H2O2? That is 2. So this is 200. Okay. So this one will be 10 raised to minus 1 in net. This one will be 1. 1 into 10 raised to minus 1, that is 0.1. So number of mole of H2O2 will be 0.1. You can choose the choice as A. Ready? What about the next question? It is a balancing question, question number 20. Cl2, the gas, plus OH minus gives YClO3 plus ZH2O plus 10 electrons. So you're asked to find the coefficients of X, Y, Z. This is XOH minus. Okay. Ready? So simply you find the oxidation state. Here 0, here plus 5. Ready? So here we have 2 chlorine. So 2 here. Okay. So the you know how to balance a oxidation half. So total change of electron, total change in electron is 5 for 1 atom into number of atom 2. So this is simply a balancing of oxidation half. 0 to plus 5. So kind of 2 atoms. Total electrons left is 10. and that 10 electron you have to add in. Right side. Then you find the charge. Then you make up it using OH minus and water, right? So the charge 0, -1. I'm sorry, 0. You leave the charge of OH minus here. Okay. So simply, let me balance it in a simple version. Cl2 gives ClO3 minus. This is the only reaction. And you know how to balance oxidation half. So put a 2 here and 0 to +5. So the change electron is 5 into number of atom to 10. So 10 electron is left. So since it is no oxidation number method, the 10 electrons are represented the right side. Then you find the charge. Here 0, here -2, here -10, here -12. So the medium is basic, right? It is clear from the question. So 12 OH minus is supplied to here. So plus 12 OH minus. So that the number of hydrogen will be 12. So here we need 6H2O. So as per the question, the coefficients are, this is X, Y, Z, I think. So X is 12, Y is 2, Z is 6. You can choose the choice as 3. Okay. Ready. No need of considering this one, this one. You simply require the skeleton. Then you know how to balance oxidation half or reduction half using half reaction method. It is already discussed in the theory, right? So section B is over.